The ability to live forever is something all of humanity desires but cannot have. But these little creatures might just hold a secret to immortality. Hey everyone, and welcome back to Trend Dive. In this video, I'll tell you about 5 animals that can live after death. So make sure to stay tuned for number 1 spot, as these creatures might just be immortal. So let's go. At number 5, we have the infamous cockroach. You shouldn't be surprised that this infamous little bug would be on this list. People have long said that cockroaches would most likely be the only survivors of a nuclear war. Some people even said that they can live with or without their heads. That's crazy, right? Let's go into a little bit more detail about these little creatures. Well, no surprise here that they can live weeks without their heads now. That is awesome. To understand how they live without their heads, first, we have to understand how we humans cannot. Well, the first thing is humans bleed. So if you cut off a human's head off, he or she will bleed a lot. Well, cockroaches don't have this. You see, cockroaches have an open circulatory system, which means little to no blood pressure. So if you cut off a cockroach's head, the wound will close up due to natural clotting. And obviously, human heads hold something very important, like brains. Even something as easy as breathing is not possible without a head. But back to these little infamous creatures, cockroaches, they don't need their heads to breathe, as they breathe through holes on their body called spiracles, which I think is pretty cool, although cockroaches will die eventually due to starvation, but this process takes weeks. At number 4, we have chickens. Yep, chickens. Come on, we all have heard the saying, running about like a headless chicken, or in my case, witnessed with my own eyes. But you haven't heard of this saying, I'll explain it, so try not to fall asleep on this one. The brain does not control all body movements. Some movements are to great extent controlled by neutral networks in the spinal cord, so stay with me. This is why a chicken can run away after you chop its head off. A new study takes a closer look at the strange phenomenon. So let's dive in head first. If you chop the head off a chicken's head, it can still run around for a few seconds. The same applies to some other animals, including the turtle, which continues swimming even though the head has come off. The animals can do this because of a neural network in their spinal cord is pre-programmed to design the muscles in various frequently used movements patterns, such as running or swimming. Despite intense research into how the body, the brain, and the nervous system works, scientists still do not have a clear picture on how nerve cells communicate to perform certain movements. Using headless animals as study participants, a team of researchers from the University of Copenhagen, Denmark, will now try to get a step closer to this understanding of this phenomenon in their new project, Attractor Network Dynamics in the spinal cord. Remember to like and subscribe. At number 3, we have the dancing squid. Dancing squid. What is that, you may ask? Well, I'll explain it all now. Soy sauce may be able to revive adult fish, but it hardly has the ability to bring dead things back to life. Yet, that's exactly what the condiment appears to do in this Japanese dish. But how does this work exactly? So how does the squid come back to life? The reaction is an automatic response to the sodium chloride or salt in the soy sauce. The recently deceased squid may lack a brain, but its muscle cells, which is received through electrical commands, are still intact. Which is cool, as humans don't have all these cool things. So anyway, back to the dancing squid. So most of the tissue in an organism that's recently dead, recently killed, is actually still alive. Charles Grisham, a chemistry professor at the University of Virginia, explains, in this case, though the brain function is missing, the tissue will still respond to stimuli. The squid's muscles still retain adenosine triphosphate, ATP, the main source of energy for muscle contractions. Therefore, when the sodium in soy sauce is absorbed into the creature's body, it triggers muscle spasms that appears to make the cephalopod dance. Of course, a specimen might be fairly fresh for soy sauce to climb this reaction, according to this report. So leave a comment on what you think about this. It's awesome, cruel, or disgusting. Would you eat this? Let me know in the comments below. At number 2, headless snakes. Now you may be thinking, oh come on, headless snakes, really? Well, studies have shown headless snakes can still kill you. Let me explain. When faced with a venomous snake, most people natural's reaction would fall into one of these 3 categories: fleeing, freezing on the spot, or oh god, there's a snake, kill it, chop off its evil head. Oh my god, it's a snake. While the latter course of action may seem like the surefire way to avoid getting bitten, it turns out that might not be the case. A snakehead that has been cut off or will refuse to do what any severed head with a shred of common decency should do, die, but also rearing and trying to bite the living crap out of anyone dumb enough to get close enough to it. So, what makes this abomination possible? The snake has heat-sensitive pits at either side of its face, which it uses to detect threats. And let's face it, if you're close enough to your body heat to be detected, you're close enough to be considered as a threat. And also, what the hell are you doing standing so close to a venomous snake head? These heat-sensitive pits are capable of detecting a threatening presence of hours after death, which means the snake may continue to defend itself. And yes, this applies even if the body is no longer attached. So anyone dumb enough to poke and prod its asses to the level of deadliness may quickly and find themselves with a sudden increase in the level of piss their pants when the snake's movement sensors kick into action. And finally, number 1, we have something terrifying: zombie frogs. Now, frogs can swim, croak, and fight, brain or no brain. So let me explain this. As those of you with ticklish feet are only too aware, if something unexpectedly brushes against your foot will automatically move away from whatever it's touching. Whether or not you then decide to punch whatever is touching it in the face depends on how ticklish you are. The exact same withdrawal reaction can be seen in frogs, except the frog doesn't even need to have a head in order for the reaction to happen. This is fairly damn impressive on its own, but let's face it, there's only so much a creature without a head can do. So what happens if you leave the frog's head intact but take out its brain, I hear you ask? Well, thanks to "let's chop out its brain and see what the hell happens" approach to science taken by 19th century neurologist David Ferrer, we can tell you a headed but brainless frog actually behaves very similarly to a frog with its gray matter perfectly intact. If you turn it upside down, it will right itself. If you pinch its feet, it'll hop away. If you put it in water, it will swim to the side and climb out. And perhaps more disturbing of all, it will even croak contentedly if you stroke its back. The first factor that results in frog zombies like tendencies is the power of the reflex reaction, which fires the necessary electrical impulses that cause a muscle to expand or contract. These reactions bypass the brain, going back to the human foot, moving away from an unexpected tickle. You don't think, something's tickling my foot and I really must move it. You think, my foot just jerked. What the hell? It was tickling it. But it's important to note this automatic withdrawal action will not continue if a human doesn't have a brain. We simply cannot survive without our gray matter, because our behavior relies on it so heavily, especially on the input from the cerebral master of our central nervous system. Even breathing, which we don't need to consciously control and could be considered a reflex action, is regulated by and therefore reliant on our brainstem. So thank you so much for watching this. If you enjoyed this video and if you want to see more, like, comment, and subscribe. And don't forget to click the bell icon so you don't miss out when we upload a new video. Thanks a lot.